So Chapter 8 is about continuing our examination of where electrons live, and then think about how those electrons and where they live relates to chemical periodicity, so how things are arranged in the periodic table. So again, there's three sort of basic kinds of problems that we're going to see in this chapter. The first is dealing with the fourth quantum number and then orbital diagrams. And so just reminding ourselves of what the three quantum numbers were that we learned from Chapter 7. The first is the principal quantum number, so that's our n, and that sort of has to do with what row you are on the periodic table. The second is our L value, and that really has to do with what your orbital is. So again, remembering where your L values run between, that is going to be indicating, an L of 0 is an s orbital, L of 1 is a p orbital, L of 2 is a d orbital, L of 3 is an f orbital. So those kind of indicate the orbitals that we have. And then we've got our m sub L values, which run between plus and minus L, all integer values, including 0. And then the new quantum number is m sub S, which is either a plus or a minus 1/2. And really that number just indicates whether an electron is spinning up or spinning down. And that has to do with the Pauli exclusion principle, which tells us that no up two electrons can be occupying the same seat. So we had sort of a baseball park analogy. Again, we love our park analogy to think about what space electrons have to sort of move around in. And so the entire park represents the atom, and then we've got levels within that. Then we've got areas where we have maybe a box, and then we have an individual row, and then we have individual seats. So the concept is that no single electron can have a single can have the same four sets of quantum numbers. You can have things that live in the same row. You could have things that live in the same kind of general area, the box, but they can't occupy the same seat. And so those four quantum numbers kind of identify that specific information. So building on that, then we actually can draw what those boxes look like with our orbital diagrams. And so our orbital diagrams allow us to physically see the homes where electrons might live, and that helps us think about concepts like whether electrons are paired or unpaired or not. So that's sort of like a big skill that we had. And then we built on that with writing electron configurations. And many of you have experience with this already. That's the whole 1s2, 2s2, 2p6, 3s2, and so forth. Figuring out for any given atom or ion, what is the orbital configuration? And these two are sort of related, that we can take an electron configuration and we can translate that into an orbital diagram, and from there get quantum numbers. So two kind of big skills with that. And then the last skill that we moved on to talk about was sort of how the periodic table is set up and how we have trends in certain properties in the periodic table. And some important trends that we talked about were atomic size. So we talked about how the size sort of decreases as you go across a row, and it increases as you go down. And so we can think about atoms becoming bigger. Obviously that makes sense as we go down. But as we go across, we have more electrons and more protons, and they're attracted more closely to one another, so that pulls electrons in and makes for a smaller atom. Thinking about atoms becoming ions, we talked about how cations are smaller than their parent ions because there's fewer electrons, and then we have more electrons with anions that become larger. We also talked about ionization energies, particularly the first ionization energy. So that's the energy that it takes to remove the first electron. And again, that's related to how tightly those electrons are held close to the nucleus. And so this is related to size, it's related to effective nuclear charge. So all of these things are kind of related, and we had some important trends that we talked about. So kind of a very qualitative chapter in that regard, but helps us kind of put together all of these pieces that allow us to explain the beauty in the periodic table.